Good morning, developers. If you are new to the channel, my name is Rob, and in this video, I'm going to shoot for roughly 1 hour to show you how to build a WebRTC app inside of React. And if you are new to WebRTC, this is the wrong video. I will drop a link in the description. It'll be the top one. I would like you to go there first, where I'll break down in detail the flow, the process concepts, and then go through some code. We will do a little bit here and there. We'll spend a little bit of time in the docs as needed, but that's not really the point of this video. And if you find yourself getting lost, again, please go there first. We'll start by going through our component structure, and then we'll talk a little bit about the process and some decisions that we have to make. We will have an app.js around the whole thing. And inside of app.js, we will have 3 components, home, and we may change the names when we get there. But we'll have home, we will have offer, video, and we will have down at the bottom here, answer video. Okay, so these are going to be our 3 top level components. And we're not going to use Redux. It is really hard to not use Redux. I've done a lot of React apps that use WebRTC, and that's a really hard one to get away from. But we're going to keep it as simple as we possibly can. And we're going to have our state up here at the top level. So we will have things like call, status. We will have video. We'll have audio. Things like that, right? Is the audio enabled? Has the call started? That kind of thing. All of that will be stored up in app.js, and it will be passed down to the components as needed. So we're going to be passing a lot of setters and so on, and that's okay. It's not my favorite thing in the world, but it will do just fine. We will have a folder, and we will call it something like WebRTC functions, and then we'll have another folder, and it will be our WebRTC components. And inside of the components folder, that's going to be things like our audio button. So when you click on that to mute yourself or enable, the video button, the hang up button, the call button, those are going to be shared inside of answer video, offer video, and then to some degree inside of home. And the way the home app, or rather the home page, is going to work, we'll have it divided into 2.5. And I'll show you this in the demo here in a minute. We will have a call button, and this will initiate a call. And then once you have clicked call, then it'll switch. We'll change the verbiage, and it says waiting for someone to answer. Over here, we will have answer buttons for all of the calls that are currently waiting for somebody to answer. In our app, it's probably just going to be one, but we've got WebRTC functions, and that leads us into our next topic. This is a really difficult video to make for a mass audience. If we were making a very specific project, we could have a very well thought out architecture that would be specific to that project. But it takes like 10 or 12 hours, at least in my experience, to code line by line through a significant React WebRTC app. And it would also be very specific to that particular purpose. I want this to be generic, so we're going to go generic. The problem with that is that WebRTC, okay, we've got these functions here, and we've got our app.js, which means we've got React. What is React? Well, it is a front-end framework, so JavaScript. It is interested primarily in managing the DOM. When should I re-render? What things are happening? How do I manipulate the DOM? That's what React's job is. It happens to be written in JavaScript because it's a front-end framework. WebRTC, what is its job? Well, it's a front-end API. Yes, we will have a signaling server, and we'll come back to that a little bit later. I will give that to you. We're not going to talk about that in this particular video. We're just going to be doing front-end. But back to base here, we've got React, which is a JavaScript front-end. We've got WebRTC, which is a JavaScript API. They both have completely different agendas. WebRTC is all about going out to the signaling server, building ICE candidates, setting up offers, SDPs, getting answers, that kind of thing, right? The only thing that WebRTC needs to do with React initially is get a video feed and give it to React. After that, it's going to be just a bunch of small stuff, the stuff that happens in these WebRTC components, the hang up button, the call button, the audio button. There is a bunch of stuff that React is going to need to tell WebRTC to do. But the question that we need to answer, or that you're going to need to answer, is who gets to drive? Who gets to be in charge of this? Because React is already async, right? I've had applications that had literally thousands of use effects in them. WebRTC is a whole nother brand of async, because we're going to have, so from our application, I'll draw it up to here. We're going to have our signaling server over here. And what's the process like? Well, the user's going to click on call. Okay, you can think about it like a gate control flow, where React opens up the gate and says, okay, someone clicked on a button. Now what needs to happen? WebRTC, go. Okay, so we're gonna get user media. Then we're going to need to create a peer connection. And then we're going to need to add some tracks to it. Once we've got tracks added to it, we're going to need to create an offer. We're going to send that up to the signaling server. We're going to have to collect ICE candidates. We're going to have to listen for ICE candidates. Right, I'm not going to go through everything, but there's a very async, crazy process that WebRTC needs to go through. So the question is, does React open the gate, and then WebRTC does its thing, and then when when WebRTC has its video feed, it hands it off? Or do you want one gate to open every single time? So get user media. Okay, when you're done, let me know. And React says, okay, now create a peer connection. When you've got it set up and you've got your event listeners, let me know. Okay, you've got those. Wait until the user clicks on add video, and then I'll tell you to create your offer, and so on, right? This is really tricky because, again, who gets to drive? They have totally different agendas. WebRTC is native JavaScript that cares only about creating offers, answers, building video feeds, that kind of thing. React's agenda is managing the DOM. They just have a tiny bit of overlap, but it's obviously incredibly important. And since both of them are confusing, in my experience, the best thing to do, if you're new, and you probably are because you're watching this video, is to let WebRTC drive. So in a normal React app, I might have dozens of APIs that React has to interact with in some form or another. And so I usually wrangle them together in the React way. With WebRTC, it is, again, if you're new, it is crazy trying to keep track of everything. So it's better to just let WebRTC be WebRTC. So what we'll do is, once there's a call, we'll open up that first gate, we'll let WebRTC do its thing, and when it's done, we'll hand it back off to React, and then React can do its thing. I'll show you when we sit down and code it out, kind of what this is going to look like. But these are pieces of state. They're going to drive a lot of that. The signaling server is obviously going to be driving a lot of that because we're going to be passing data up. We're going to be waiting for data to come back. Some of that is just going to be old-fashioned JavaScript event listeners, and they're going to need to trigger things inside of React. They're going to be socket handlers inside of React, and socket.io or WebSockets inside of React is itself pretty confusing too. So this is going to be fun. It's just going to be a simple homepage. We'll have a main, our two video pages, which I'll show you in a sec. Will be pretty straightforward. And hopefully when you are done, you'll be ready to move forward on your own app or ask the right questions, that kind of thing, okay? We'll come back here if we need to, but let's go code. Before we start coding, I want to show you a demo of what we are about to make. And even though you are seeing it before we code, I am making it after we code. In fact, I literally finished about 5 minutes ago, and I had to make a few adjustments. Up here, the IP address is now my local network rather than local host, which is what we use in the demo. You'll have to make that adjustment yourself, but you are seeing literally what we are about to make. I'm going to punch in here Rob Windows as my username because my other machine is my Mac. You can see up here we're at the home page. I click OK. It just rewrites the home page. If I click on Start Call, my video feed kicks in. It didn't ask for permission because I've already granted permission. But nothing happens now until we enable the video. The audio button does not work. You can easily fix that if you would like to. The hang up button I'll show you in a minute. If I click Start Video, it says awaiting answer, and we have a bunch of chatter that happened down below. If I go to my Mac and I log in as Rob Mac and I answer the call, start the video, Windows, Mac. And this is awkward. If I stop the video on my Mac, it goes black over here, and I hang up. Well, I already hung up on this side. Click hang up on this side, and everything goes down. Refresh, and I will start it from the other side here from my Mac. So we'll do Rob Mac 2, start the call, and enable the video over here. Now join Rob Windows 2. We get answer call from Mac 2. I answer, the video kicks in. Once again, I have to enable. And here we are again, Windows and Mac. And if I can shut down my feed. From this side, it stops showing there, but I can still see the remote feed. If I click hang up, it goes down. I have turned my video feedback on because I really prefer to teach this way, but at some point it just won't be practical anymore as we're moving back and forth between our code editor and our app. My camera will be fighting itself, so that will come and go. There are 2 GitHub links in the description. One is for the final code, and other than some comments, that should be exactly where we finish, and it will be the same as the demo you just saw. The starter code, I want you to download this however you get your code and open it up in your code editor. We cannot type every line together. I would love to do that, and I have a couple resources for you that I'll drop into the description as well if you would like that. I don't have anything to offer you on YouTube because it's simply not practical. React's not meant to make tiny things. You don't make log cabins or tents with it. You make cities. So either we have a 10 or 15 hour line by line to get even to just the beginnings of a site, or we make something so irrelevant that it's not worth the time, especially when React's going to complicate everything. So I'll drop those courses in the description if you're looking for more. Again, they will cost money, and I'm not trying to extract money from you, but it's the only thing that I have to offer at the moment. In addition to that, I have the video I mentioned on WebRTC where I go over all the concepts. That will be really useful as well. I have one that is just on socket.io, and so I pulled up the server file. I'm using VS Code. This is our signaling server, and it uses socket.io. So if you really want to learn more about socket.io and you want to know what's going on here, I'll drop that video in as well. And then I have another one that goes over setting up your local for an app that's going to use React, WebRTC, and socket.io and HTTPS. And what I showed you in the demo is literally what I made it when we got to the end here. It should work, right? I hope it does, but I can't promise that it will. It works on my computer in April of 2024 on my browsers, my network. Okay, I don't know what network variables you have to deal with. I don't know what browser, the state of WebRTC, any of that. So if it doesn't work, that would be a good resource to go to as well. Ultimately, my goal is not to help you get this thing going. It's to teach you how to use React and WebRTC together. I hope that this is your dream app and you build a huge business off of it, but those are some of the constraints that we are working off of. The code here for the backend, I pulled from that first video that I mentioned, the WebRTC going over the concepts and stuff. This should almost be exactly the same as when we go over it there. If there are any substantial changes on either the front end or the back end, look for this. This is how I will denote a major change, something like this, okay? So it will follow this. Otherwise, I may make some comments along the way and I may change some small things, but nothing that would actually affect your code unless you see something like this. Going over to the terminal window here, if you go down into the backend folder, because there are 2 folders, a front and a back, I want you to run npm install on the back end, and then I'm going to open up a second terminal window. I'm going to go into the front end, and I'm going to run npm install here as well. So please kick those off. The front end will take a second. Looking briefly at our back end, in the server, there are a few small things I guess I want to bring out. I am not using HTTPS. The reason for that is because the browsers are getting more finicky about supporting across origin certificates that aren't valid. So I have here using makecert a way to create an HTTPS server, but without importing your certificate into your browser, none of my browsers would work. And I don't want to take the time to do that. Again, you can check out that other video that I mentioned. But instead, if you just run HTTP, it should theoretically work. Again, I don't know the status of the browsers or any of that, but if you want to bring that back in, you'll need a line 21 here. These are how I make local certificates, and then you'd comment this line 23 out. The other thing is here when we make our socket server on my line 28, if you're running a React app somewhere other than this domain, you'll need to change that. So as a for instance, maybe you're running on port 3001, because like me, you have more than one Create React app running, then sometimes I'll add both of them. Make a note, this is HTTPS. This part is. The backend is not. Backend is regular HTTP. So React is going to be going to a standard HTTP port. This is going to HTTPS because we have to run Create React app securely or get user media might not work for you. So that's what we've got there. Just make sure that you've got all the appropriate domains. I am listing on port 8181 here for the back end. So our signaling server, that's pretty much all we're going to talk about it. Port 8181, and it will allow traffic from these places, and it's running on standard HTTP. If there's more that you want to know, you can look through it. I am expecting up at the top a username and a password. The password has to be the letter X or it will disconnect you. This is just for your reference if you wanted to do some authentication or something with this particular app. So let's close down server.js, come back over to the terminal, and let's fire up our apps. I'm going to run nodemon on server.js. I don't know why it typed out like that. There we go. Nodemon on server.js. Make sure you don't have any errors. We're going to test our connection first thing here. Over to the front end, we need to run this securely. And I made this app with Create React Apps. So this page using HTTPS in development, Create React App comes with the ability to automatically run it HTTPS. It uses a self-signed certificate. I'm on my Windows machine, so I'm going to use this command. Use the appropriate one if you're on Linux or Windows, whatever. I guess Windows terminal. But down below, you can make your own SSL. Again, I have a video on that. Hopefully this will work for you. I haven't had any issues with it. But I pasted that command in, even though it looks very strange. And this pops up for me. You probably will get a privacy here saying, hey, this isn't safe. This certificate is bogus. That's because you just created it. You'll get this lovely join button. Click on that and it brings you here. Click on start call. Absolutely nothing else happens. That is where we come in. So back over to our front end folder. Let's test that connection out. I want you to open up the SRC folder and then components and then go to the home component. If you scroll down on line 24 through 29 here, I want you to bring this use effect back in. This will test the connection, and we'll look at this file a little bit later. It is important that you uncomment this when we are done because this will screw up our connection. If you come back over, you should get Pong. You probably get it twice because React will automatically, when in strict mode, Create React App will render everything twice, so you should see it twice. You can refresh just to make sure. But if you have errors, work through them and then again, comment that out. This is just to make sure that you have a valid connection that's going on, okay? Up at the very top of our application, let's go up to let's go to index.html quick. A brief interruption to go over something very important up front. This, please pay attention here. What I have provided you, if I open up the server again quickly, this is not bulletproof. I could make it mostly bulletproof and it would be totally unreadable because there'd be thousands of lines, all kinds of error handling and whatnot. I try to keep it simple so it is as readable as possible. That means that you can add changes if you're getting errors, but there will be times when, for instance, if you have the same username, I don't have a good check to make sure that you don't collide with each other. So you might have exactly the same code that I do and it doesn't work because remember, we have 3 different things that they're all working asynchronously. Socket.io or WebSockets in server.js, we have React doing its thing, WebRTC doing its thing, and WebRTC, of course, is divided into 2 pieces, the offerer and the answer, so 2 different clients. So there are 4 different places. If you end up with a weird error and you don't know why, the best thing you can do is to kill the server, come back over to any of the browser windows you have open and refresh them so you definitely have disconnected the sockets, and then restart the server and then go through the process as you would normally. Again, this will help make sure that you don't have any caching issues because React or WebRTC might be sending stuff up because Webpack constantly reloads itself. The server may be emitting stuff that you're not paying attention to. All of those things, you'll get better as you do WebRTC, Socket.io, etc. But again, killing the server, refreshing the browser with the server down, and then starting the server back up will save you so many problems, okay? So back over to index.html. The only thing I put in here, this is exactly what Create React App comes with. I've added Bootstrap and Font Awesome so that we can grab the Font Awesome video and mic icons. If we go down to index.js, this is exactly what it ships with, other than I commented or I deleted a few things. If we go to app.js, and app.css is where pretty much all of my CSS is at. So if you want to play with this, that's not true. There's a video page CSS, but if you want to change things, They're scattered here and there. Inside of app, we bring in app.css and we grab the browser router. So let's look at that real quick. Browser router wraps around routes, which wraps around each individual route. So this is the way we do our navigation. The slash path goes to the home component. The offer route goes to the caller video component, and answer goes to answer video component. I pretty much am passing every piece of state down to each one. Going back up here, there are 6 different pieces of state. I wish we had Redux. It would be a lot easier, except it wouldn't be because we'd have a lot more code to worry about. But these are all set up here either because we use them in some function or we use them in more than one component. Anything local, I have set up locally. That's pretty much all app.js does. Is it handles our navigation. We've got our home component, caller video, and answer video. Those again are our top level components. So we're pretty much done with app. Let's take a look. We'll start at home, which again is this page. Let's look at our state. We have a type of call, and that will be offer or answer. You'll see that in a minute. Joined is how we determine whether to show the joined button or the answer and the call buttons. Available calls, these are all of the calls that are waiting for an answer, and we'll come back to this in a second. Navigate we'll use a little bit later when we're ready to drop that in. Let's go down to the DOM. We've got 2 different return statements. So if joined is false, and going back up, it is on load. So it will start off as false. If joined is false, then return this. This gives us our join button. If you click on join, it switches joined over to true. So scrolling down, if joined is true, then we'll get this return statement, bootstrap, and then we've got half the screen with the make a call area. That has a call, click listener, we'll come back to that. The other half, or the right half of the screen, is the call section. These are the calls that we've gotten from the server that are waiting for somebody to answer them. So those are the 2 things where we are at. Nothing happens until join gets clicked on. So if we come all the way back up to the top here, we've got a use effect on line 31. Comment here, nothing happens until the user clicks join. This helps with React's double render problem. Again, in React strict mode, you're going to get 2 renders of every component, so this kind of slows that down, keeps us from having to write some extra logic. What goes inside here? Well, if the user just joined, so this is going to be false on load. Once the user clicks on it, it will go away. We are going to do 2 things. We're going to collect their username, and you're probably not going to like this, but we don't have time to do anything fancier. We're going to use a good old-fashioned prompt, and this will block our program, and it will serve our purposes just fine. Again, you can make a nicer UI if you want to, and then we will set it. The other thing we need to do is actually initiate the socket connection, and we will hand the username we were just given here on line 35. That's why I said back up top here with our in our test, we pass test into the socket connection. You'll see that in a second, but this is supposed to be the username, and you won't want to use that. So initiate the socket connection, and we'll do a socket.on. We're going to listen for available offers. We'll talk through that in a second. And socket.on, new offer waiting. These are both defined events on the back end. So if you want to go look at the socket.io server, these are signaling, fetching the offers that we have. And we're going to run a function. Let's define it here. We'll call it set calls. We probably don't need this, but we're going to bring in data, and this is where we'll run set available calls, and then let's console.log the data. Okay, we're going to need to talk through this, but let's make sure we run set calls here. Once the user clicks on join. So back over to our app, right? Join is currently false. I click on it. It is now true. So our username prompt fires. I'm going to put in here Rob and click OK. It drops us on the join page. We don't have any calls waiting, so nothing populates down here. Let's go take a look. This was the line that just ran. We set our username, and then we built our socket. So let's go take a look at that, and we added 2 listeners to it. Socket connection, you can see it up in the top here, line 3. But in WebRTC utilities, we've got socket connection. This thing brings in the I/O from socket.io client. That's in package.json. You installed it when you ran npm install. We have a variable for our socket, and then we have our socket connection, which is what we export. So this is the thing that's going to get dumped out there. Expect a username. So back over to home, that was what we sent over here, test. And now that's what we're sending in here when we build our socket connection is the username. If there's already a socket and the socket is connected, so it won't be true the very first time this runs, we will skip over this. So we go to the else. It's not connected, so connect. This is how we make a connection on the front end. We call io.connect. We hand it our URL. This is our back end. Remember, there's no S here. So if you're using a secure server, you'll need to add the S in there and whatever the correct domain is. But we connect here, and then I've got an example here where I connected to my network or my local IP. We pass it an auth object, and this thing has a password property of X, and then the username that was passed into the function. This password has to come through, or the auth will fail. If you want to change this or change the signaling server, the socket.io server, you sure can, but I put that in there again for reference. Down here, if the username is test, then this is where that ping runs, and that's why Pong shows up to just test it out. So this is just for testing. This happens though that first time when we have no socket or the socket is not connected. The next time we run this file, there will be a socket and it will be connected, so we will simply return the socket. That's easy enough. That builds our socket connection, so we have socket.on, socket.emit, etc. for the front end, and we listen for 2 events from our signaling server for the available offers and new offers waiting. Available offers means there are already a bunch of offers when we connect for the first time. So this will get sent out as soon as we join. This one means we were already on the website, and then someone created an offer, so this will fire off that way. And I'm trying to avoid it, but I guess we'll go ahead and look at the server real quick just so that you have a frame of reference here. In the back end, if you open up the server, we have a back up here on connection. So someone just connected. This is where we check to see what their password is. If it's not X, then we disconnect them, so you can remove that. We push their socket onto connected sockets, and then down here, this was our testing connectivity where we send back Pong. If there's something in the offers array, then we emit available offers. So if I comment that out, come back over to our app, and it's already got the array down there, but I'll go ahead and punch in Rob. We get it again. I'll refresh, join. Let's make sure that worked. There we go. We don't have any offers, so nothing came through. Let's bring that back in, go down a little bit. Anytime a new offer comes in, at the bottom, the last thing we do is we emit the new offer waiting event. So that's how that is handled. These 2 things right here will make sure that that any answers that are available will show up. So join has, this is cleared, and we have any available calls. We're mapping through them and putting them in there. Again, we don't have any, so we're gonna have to do this one. Click call. Let's go up and check that one out. Now, this is a decision that you can make. I separated these 2 so that one calls the call function, the other one calls the answer function. They do exactly the same thing almost. In our case, one of them just sends call data, the other one doesn't. The reason I do this is because it helps keep things clear. A lot of times there's business logic that's specific to one or the other. You can merge them if it bothers you. We are going to call init call, and we are going to pass offer, and then for answer, we are going to call init call, and we are going to pass answer. So they're going to do the same thing. They're more than anything placeholders. We can go ahead and do it now. We'll have to talk about it later, but we're going to need to set the offer data eventually with the call data. Again, we're quite a ways away from talking about answers, but that is the only business logic that's specific to the answer. If we come down here again, just to show you, if the user clicks on answer, we grab call data. Where does call data come from? Well, we're mapping through this array. This is what got set back up here from set calls. One of these 2 things happened. So we ran set available calls. We passed it data. Data came from our socket.io or from our signaling server. So we're mapping through that, and we're sending the call data up to answer. That's what that is. Again, don't worry about that yet. We will have, oops, lost my place there. We will come back to that when it's time to talk about answers. In the meantime, let's go up and let's look at init call. Init's call job is going to be to set the local stream and get user media, so GUM. I like to have this in a separate file, so we're going to do await prep for call open, close. If you scroll up, that function is brought in here on line 2. We will go over and look at that in WebRTC utilities. And if we open that, let's open that up. All right, this is WebRTC 101. We need this data, so let's copy this, go back over to home, and drop those things in. Call status, update status, and set local streams. Those are all coming in from app. So these are sort of top level pieces of state. Inside prep for call, we're not going to write this because we don't need to. This returns a promise because stream has an await inside of it. So back over here, that's what our await is waiting for this thing to resolve. We've got video as true, and I have audio as false because audio coming through as false tends to create feedback when I'm testing, and I don't want that. You have to have at least one constraint, but we don't have to show it yet, and we don't. So just because this is going to show up in the user's feed, or I guess the user's video tag, it won't show up on the remote stream. What are we doing here? Well, we run a try, grab or get user media here with those constraints, and block the program until that happens. Once that has happened, we make a copy of call status, we update have media to true, video enabled is set to null, not true and not false. Null is going to be basically our init value. You'll see that in a minute. And audio is set to false. So both audio and video are disabled, even though we're going to show them in their video tag. We run update call status so that those 3 pieces of data will get updated back up in app.js. We set the local stream, the stream we brought in here with get user media, and then we call resolve. If an error happens, then we reject and I log the error. So, just if you get an error, deal with it, of course, but hopefully you won't, because this should do what we want, unless the user decides to deny access, and in that case, it will be their problem, at least the way the app is set up. We are also going to do set type of call, and we're going to hand the type of call that was passed up. So this is going to be either offer or answer. I guess we've already got that there, but that's all init call does. So we've got a little bit of a trail here just to make sure that this is clear. The user clicks on join, which is in this section here. So on the app, let's refresh. We're waiting. You click join, back over to our code, go up to our use effect. Join is now true. So collect their username, set their username, create a socket connection. This will be the first time. And then listen for these 2 events. If one of them happens, then run this code. Meanwhile, because joined is no longer true, we build the left half of the screen with our call area. We build the right half with our available calls, which we are mapping through. If the user clicks on call, and that's all we have right now because we don't have any offers to answer, we run this function and we pass offer, we run this function, or we pass that if it's an answer. The only thing init call does is it simply runs prep for call, and then it sets the type. So you can merge these all into one place. I like to keep them separate because, again, there tends to be a lot of business logic for any of them. Okay, so what happens now? Well, we have been waiting back over here for the user to initiate a call. So click on call, and it's going to make a request for get user media. I have already enabled that. Nothing happens, so you can't tell that anything happened. Over to our code, we can go ahead and throw in a console.log here just as a test. Gum access granted. So run it again. I'll put in Rob. Start call. There we go. Gum access has been granted. I have already granted it. If it's for this particular domain, you can always disable it. It looks like it's over here. So there we go. You get the idea. I'm going to comment that line out. What happens now? Well, we'll scroll down. Nothing happens till the user click join. We've got that covered. This one up here, this is going to get called on call or answer. Well, now we need to wait until we have the media. So if we come back over to our prep for call, which is in WebRTC utilities, that gets dropped in right here, line 18. We set have media to true. So we'll have it once this await is done. So init call is going to lead into this. If you wanted to merge these two, you absolutely could. As I said, you get to decide whether React drives or whether WebRTC drives. In this case, React closed the door and is opening it as soon as this piece of state is available. This is definitely how I prefer to write it because you can control the flow a little bit better. What happens in here? Well, if call status dot media and we have no peer connection. So that's our comment here. We have get user media. So the user has granted us access to the video camera, but we haven't set up a peer connection. That is to keep this from running over and over. That's why we've got this. We need to set up our peer connection with our listeners. So this code will run. We can make a note here. Prep for call has finished running and updated call status. So we're ready to move on. We'll do a const. We will grab peer connection and remote stream. This is going to come from create peer connection. And we will pass into that the username, you'll see why, and we will pass in the type of call. So create peer connection. I have defined up here on line 6. Let's open up our file structure here, go to WebRTC utilities. We've got create peer connection. So this is one we're gonna have to add our listeners, but it's expecting the username and it's expecting the type of call. I've got a token in here, so if you wanted to use JSON Web Tokens, this is where I usually define them. That's gonna require Redux. We're not using Redux, we're using just local state. Line 8, we create a socket connection just like we did back over in home. Now we should already have it because they can't get this far without clicking on joined, but you get the idea. Make the connection, we'll already have it, so just return it. In our try, we make an RTC peer connection with peer configuration. What's peer configuration? Well, up on line 1, that is coming from our stunservers.js. Open this file up. I have put in here Google's two stun server URLs. If you want to use other stun servers or turn servers or something like that, this peer connection is set up for that. We have an object with an ICE servers property and an array. If we look at the constructor here on MDN, we got RTC peer connection constructor. If you make a new one, and that's exactly what we're doing here on line 10, we get that exact code, then you can pass in configuration. We've got, the bundle policy we're not using, certificates, keep going. The ICE servers is what we are using. You can look through this. Again, this is sort of WebRTC 101. We're passing those stun servers in. And then on line 14, we create a new media stream to be set inside of our remote stream. And we pass both of those back, the peer connection and the remote stream. Now this part here, line 17, we need to add a bunch of listeners. I choose to keep them here because I like them in one place where the peer connection is created. So we're going to go peer connection dot add event listener. What listener? Well, again, we can go over to the docs, but we're going to look for a couple things. Signaling state change. Over to the docs. Under events here, we've got signaling state change. This is really useful. It will notify that a signaling change or signaling state has changed. You can see what the options are and all of that stuff here. This is really, really useful for troubleshooting. So we'll drop in there the event and we'll put in here console.log signaling event change exclamation point because we're really excited. Let's console.log the event just so we can see it. And then what usually is what you're going to be after is going to be peer connection. Oh, and it looks like on line 17 there, I am sorry. This should not be peer configuration. That should be peer connection. Visual Studio Code picked the wrong one. But what we'll be interested in here is going to be the signaling state. This is a property that belongs on peer connection. So you'll get notified. You'll get the whole event for this particular event. But usually what you'll be interested in is the signaling state. The next one we'll do, so we'll do another peer connection dot add event listener. We are going to listen for ICE candidates. Over to the docs again, scroll up a little bit. That's another event that belongs on peer connections. This is going to get called when an ICE candidate has been found and added to the local peer by calling set local description. So it's going to be the offer or the answer has happened locally, and we've set that, so now we can go out and find some ICE candidates. We are going to bring in, once again, the event, and let's put in here console.log found an ICE candidate. Let's make an explanation point again because we're excited. If e.candidate, so we're only going to move forward if there's an actual candidate, then we are going to emit the new ICE candidate to the signaling server. You've got a decision to make here. I prefer the event listener, the ICE candidate event listener belongs to PeerConnection, so I'm putting it in this file. I understand the argument if you want to put this in your socket listeners file or something to do with your sockets, but we are going to need to emit to the signaling server. So we've got a PeerConnection listener and a socket emitter. So it's up to you how you want to organize this. We are going to emit the send ICE candidate to signaling server. And you can double check this if you go back over to server and do a quick search for it. It is quite long, but I did that on purpose. I wanted it to be very explicit so we know exactly what this thing does. We need to pass an object up because the backend is going to expect the ICE candidate itself. So we have ICE candidate property, and it will be e.candidate as a value. The ICE username is going to be the username which we brought in the function up top here. And then did I offer, the backend is going to expect that as well. Type of call, does that equal offer? So this is a Boolean that the backend is going to expect either true or false if the type of call is an offer, and for this particular case it will be because the user clicked on call. It will set that up. Okay, another listener we're going to add, PeerConnection dot add event listener. We are going to listen for the track event, and over to the docs, you can see that one is at the bottom here, again under events. Click on track. This event is sent to the event handler on a PeerConnection after a new track has been added to the receiver, which is part of the connection. That means the other side has sent us a track. So what do we want to do? Let's go ahead and throw that in there. The remote has sent us a track. Hooray, this is very exciting. Let's add it to our remote stream. So we will grab our event. We will go to .streams. We're going to grab the first one. That's just how it works. It's an array, and it will usually only ever have one thing. Get tracks, because we don't know if it's an audio or a video. And then we'll do a for each, call the thing we got track, and do remote stream dot add track, the track, and then associate it with the remote stream. And we'll throw in here console.log. This should add some video or audio to the remote feed. So this is where you cross your fingers. This is going to be the absolute last thing that happens, is this event has gotten something from the other side. That means our offer has been accepted, or our answer has. The other side has sent us ICE candidates. We've done the same, and we actually have a track coming through. So we're going to loop through them. So for each, get tracks. Get tracks from what? Get tracks from the stream. What stream? Well, the stream that we just got from our PeerConnection. So that's this ridiculous line. Call the thing we're on track and add it to our remote stream. Why does this matter? Well, if we come back over to down below, you don't need to come here, I guess, yet, but caller video, inside of this div, this is where our local and remote feed are. We are going to set that when we get here, and the remote feed element will end up with that data inside of it. Okay, back over to home. So where we just were, we have called create PeerConnection. We pass the username and we pass the type of call. Inside of create PeerConnection, we have the username and the type of call. We've got our constant of token if you want to add that. We've made our socket connection. We've created a new PeerConnection with our stun servers or whatever you've got that will collect ICE candidates for us. We've set up our remote stream. This is going to be used everywhere, and we are going to return it down at the bottom. So those two things get sent back over to home. We are destructuring the object that we get back with those two pieces of data. So PeerConnection and remote stream, they will be used throughout our app. We add a couple of event listeners. This one listens for signaling state changes, which is useful for troubleshooting. ICE candidate, that means we have identified an ICE candidate and we need to send it up to the server. and then we got a track, which means we're ready to update our remote stream. Just a couple things left to do here, and I know that this is a ton, but really most of the stuff happens in just home and caller, and then we will reproduce it in our answer. We're going to take the peer connection and the remote stream and run set peer connection and hand it our peer connection. That way this variable or this peer connection we made will be available throughout our app, and then we'll do set remote stream and we will hand it the remote stream we just got back right here. So with those two, particularly with our peer connection, we can go on to our next gate or our next use effect right here. We know what type of client this is. That happened back up inside of a init call. We set the type of call, which was offer or answer. We also have the peer connection now. The peer connection was just set. So as soon as this use effect finishes running, then we are ready to add some socket listeners. So we'll hop over to that file in a second, but we need to make sure that type of call exists, and we need to make sure that the peer connection exists. If both of those is true, we're going to need our socket, and you'll see why in a second. So socket connection, open, close, and we'll hand it username. We are going to call client socket listeners, open, close. That is defined up at the very top here. So I've already written that file, and we'll go look at it. But client socket listeners is going to take some arguments. Actually, let's just go look at it right now. It is inside WebRTC utilities. It's the top file here, client socket listeners. This has two listeners inside of it. This is our socket server or our signaling server, which is going to send out to us an answer response. So this will only technically be relevant to the offer or the caller, but hey, I have an answer for you. The signaling server will push that out and we will be listening for it. And then received ICE candidate from server, that's both sides. That means the peer connection on the other side has found an ICE candidate, has sent it up to the socket server has sent it down to us, and we are ready to add it to our peer connection. So the one that we looked at a minute ago here, peer connection ICE candidate, this thing, that means we found a way to get to us. Over here, this means the other client has found a way to get to them, and we're going to add that ICE candidate to our peer connection. So that's why we need the peer connection here at the end. The rest of this stuff is all going to be updates. If we get an answer back, again, we are the offerer and someone on the other side has created an answer. The socket server has sent it out. We're going to make a copy of call status. We're going to add that answer, add our role, which is always going to be offer, but it's set up that way anyway. And then we will update the call status. So we need call status so we can make a copy of it, update call status, the peer connection part down below. The type of call, again, we already know that it's offer, but it's there. The socket, that has to be sent in because these listeners are getting added. I usually will have this file somewhere in the application as kind of a catch-all so that if I'm trying to remember where are the listeners at for this particular client, they'll all be in that one place. So back over to home, I'm going to paste those in, the socket, the type of call, call status, update call status, and peer connection. And that will cover this use effect. Its only job, once the peer connection has been created, we can go ahead and add those two listeners. Down below, the remote stream and the peer connection. This is going to happen at the same time because these will be ready to go as soon as this finishes. So again, one gate closes, this one, and then this one opens up. I like keeping them separate. So rather than having both pieces of logic in the same place, I'm keeping them separate. But inside here, once we've got both of those, we are ready to move the user forward. So we are going to call navigate. We're going to navigate to slash, and then we'll switch over into template literal mode. We're going to go to type of call. So we're going to navigate to slash answer or slash offer, depending on which button the user clicked. What is navigate? At the top of our file, we have the navigate defined right here, 16. It is the use navigate hook, which comes from React Router DOM. So this is something that is built into React Router DOM. We are ready to navigate to slash offer slash answer. If you want to, I'll throw it in there. We do not use it, so please don't be confused. But the JWT part, I would throw something in here. I'll just do math.random. This does absolutely nothing. But if the user were to refresh the page in just a second, You could pull down that JWT, get the data out of it, send it up to the server, that kind of thing. This won't do anything. It is just there as an example. That is this useEffects only job. I don't know why this one is here. I'm going to delete that because we don't use it. But we've got a useEffect that navigates once the peer connection is ready, remote stream is ready, and we have one that sets up our socket.io listeners once the peer connection is ready, so that we can add ICE candidates as they come in. So I know this part is a little bit confusing because we are listening for socket server stuff to get ICE candidates, and then we're going to use the peer connection to add those ICE candidates to it. Just look over the code, be patient and be slow, and it will all make sense. We are now ready to move over to the caller video page. We will hit this page because on home here, we just navigated to /offer. What is in here? Well, we've got some state up at the top, remote feed L and local feed L. These are use reference hooks. So this is if you're not familiar with them, this is the correct way to interact with the DOM using React. If we go down and look at the DOM, we've got one div wrapper. Inside of it, there are two. There's one that holds the videos. This is the local video feed. That's the small video box in the right corner. And then the remote feed is the big one. You could rename them if you wanted to make it so that you could switch which is the big feed. I'm trying to keep things as simple and straightforward as possible, so I labeled them this way. The action buttons, we looked at that in the video message box. This is just text to kind of keep the user informed of where process is at. We need to add some use effects. So the first one is we want to send the user back home if there's no local stream. Believe me, this one will get really annoying as you're testing and the server's automatically restarting itself. If there is no local stream, then we are going to use navigate, which I brought in here on line 11, navigate back to /. If you want to do more than that or do some more checks or whatever, that is just fine. The set video tags, you could put these two things together. We may end up doing that, I don't know. But just keeping them separate, once we get to this page, we need to grab the remote video L, grab current, the SRC object, and set it equal to the remote stream. Remote stream. Remote stream is a prop that comes in. That's thanks to the to app.js or the React router. I'm going to copy this, drop it on the next line. We're going to do the exact same thing with the local feed L, except we will of course use the local stream. You can take both of these and you can put them inside of an else like this. It is totally up to you if we don't have the local stream. In fact, I'll go ahead and do that. I'll comment this out and I'll copy this comment and put it in there. If there is no local stream, send them back to homepage. If there is a local stream, then update the two video tags so they will be waiting for media tracks whenever the time comes. Okay, so those are our first two use effects. Let's test this out, and we are stuck. I have made a mistake. Back over to home and the navigate. Yes, it says right here in our comment, once remote stream and PC are ready, then navigate. We're not waiting for them to be ready. We are just running this as dependencies. We have to put in here if remote stream and peer connection, then and only then let's put our navigate inside of that. Now we will only move forward once those exist. Come back over and refresh or hit enter, I guess. There we go, back at localhost 3000, join. I will join as Rob, make a call. This should dump me on the new page. It does, there I am down below. So our video tag is showing up. You can see the spinning behind there, you can faintly see it, but our remote feed has loaded, it just doesn't have any tracks. So that's why it's spinning and this video box is waiting. The start video button, if I click on it, nothing happens. And that is exactly where we are at. Let's come back over to our caller video and let's look at the DOM because we pretty much are stuck now. We have to wait for the other user to show up. We have the video message box only briefly because this is not super important and it's not super complicated. We get a message. If the message exists, then we render this div to the screen with the message inside of it. Otherwise, we just have an empty div tag. The video message gets set. Oh, let's hop back up to the top. On load, it's please enable video to start. Where else does this get called? Well, right now, nowhere. We don't set it If we come to the bottom here, in our action buttons, open that file up. So in action buttons, this just has the audio button and the video button inside of it. If we go into the video button, we've got a little bit of HTML here, or markup. We need to finish out this start and stop video because we cannot create an offer until this is filled out. So looking at our markup, we have a button on click, start, stop video. And as I mentioned back at the beginning, we've got some fun, awesome icons in here. So we've got the caret up. This doesn't do anything, but this gives you that arrow so that if you wanted to add the devices, the available devices, you could. And then we've got the camera, that is the fun, awesome video button. So that's where that icon is coming in. If the user clicks on that, then start, stop video gets called. That's this function. We've got some code to write here. This is how we will make it so that we can actually enable the video. And again, without video enabled or without tracks added to the peer connection, we can't create an offer, so there won't be anything to show anybody else. So this is our next stop. What do we do in here? Well, we've got a couple use cases. So use cases number 1, video is enabled, so we need to disable it. That means that the user has already granted video, and I'm putting them in this order. It's a little bit backwards because where we're at in the application, they haven't done anything. But it's easier, I think it's better to first check to see if it's enabled. That way, that use case is always hit first, because if the user wants to disable video and we don't, and they think their video is off, that would be really bad. So that's the first thing. Video is disabled, so we need to enable. The last case, video is null, so we need to init. That is where we are at. We're in use case number 3. Let's put our if statements in here. We'll have if. Where's this stored at? Well, it's stored at in our call status. That is a prop that's passed down. It's coming down from app, so it's at the very top. We set this, if you remember, a long time ago inside of our, I think we'll have to open it up here, inside of init. It was prep for call. We set our call status, so we did get user media. This was the very first thing that happened. We made a copy of call status. I'm going to copy this line because we're about to use it. Have media is true, but video enabled is null. So that's where we're coming from. We'll paste that line and we have a copy of our call status. The first thing we'll check here is if copy call status dot video enabled. If that's true, then disable. Else if, be the same thing here, but we'll just do it if it equals false. And I'm not doing if it's not true because we have null. You can handle this however you want. That's just how I happen to do it. And that is our use case number 2. I guess I'll put that one in there, and I'll move this one inside here so it is consistent. Our last one will be the same here. If video status if video enabled equals null, that is our final case. We need to initialize. So that's where we're at. That'll be the first thing we do here. It is really useful to put for yourself just something like start video, or maybe let's do init video. This is just for yourself. If you don't need it, don't put it. We're going to grab a copy call status. We're going to set video enabled equal to true so that the next time the user clicks on it, this first one will run. Just making sure that that's the very first thing we do. Again, we want to keep trust. We'll keep trust of our users. We always want to make that a top priority. We're not sending video if they don't think we are. We'll call update call status, and we will hand it this new variable. And we are ready to go to the local stream. That's an argument that's getting passed in here. Going to go to the local stream, run get tracks open close dot for each. Call the one we're on track. Go to our peer connection dot add track. We're going to grab the track and associate it with our local stream. If you remember, we just did this back over in create peer connection. We have at the bottom our track listener. So this is an event listener on our peer connection. We are listening for tracks. That means they have sent us one from the other side. We loop through that and we do exactly the same thing. We just do it on a remote stream. Here we are over in video button. We, or the local user, has clicked the video button, so we want to loop through the exact same process. It's just a local stream instead of the track that just came through. Grab the tracks and add them to our local stream part of the peer connection. That's going to make it so that we can send them to the other side. So this isn't, let's make that note here. We are not adding tracks so they are visible in the video tag. We are adding them to the peer connection so they can be sent. I want to make sure that that's clear. Over in caller video, we had this line here, this local stream. That is how, that's why we're adding our video to that little box down there. The video button, that's not what we're doing. We're adding it to the peer connection, which is how the video is going to get to the other side. Since we are here, let's copy our call status. Copy both of these lines because we're going to need to do that in all three here. For this first one, if the video is already enabled, we're going to disable it. So I'm going to paste those in. We're going to need, we've already got our copy of call status. So start, stop, we just clicked, get a new copy of call status, flip video enable over to false, and update that variable. Now we need to go through and do exactly the opposite here. We need to pull them off. So const, we'll do tracks equals local stream dot get video tracks open close. This is a built-in method on a media stream. We're going to grab all the video tracks, do a tracks.for each, call the one we're on track, and set track.enabled to false. This will make it so that our local stream no longer has any video tracks, and down here the peer connection will stop streaming them because they have been disabled. This is the correct way to disable video feed in a peer connection. We are going to do the exact opposite. So I'm going to copy all of this code and I'm going to drop it in number 2 here. Let's paste that in. We're going to switch it over to true. Okay, it was false, now it's true. Update call status, grab the tracks exactly the same way, loop through them, but instead we're going to set enabled to true. That will, again, re-enable them on the peer connection, and that is all we need here for our video button. Okay, so just real quick review. User clicked on start stop video. So the first thing we do is make a copy of the call status as it currently is. If the video is enabled, then we need to disable it. So overwrite it, update our state variable, grab the local video tracks, and change the track to disabled. Scroll down a little farther. If it's disabled, then we need to do exactly the opposite. We just did that. If it's null, that means we are still in this fresh phase here from prep for call. It's null, that means we need to initialize everything, so we're going to add the tracks to the peer connection. You can, I guess if you want to be super careful, you could remove the tracks from the peer connection. You're going to have a little bit of a problem though adding them back. You're going to add a lot of extra messy logic. If you want to do that, I'll let you chase that down, but this will do exactly what we need it to do. Over to our app to test it out, let's click join. I'll be Rob with an extra B, start call. The video feed pops up, there I am, please enable video to start. If I click start video, there we go, init video ran. Now nothing else has happened, at least that we know of. Over to our code, init video ran, so presumably this has happened. Now that it has happened, we are ready inside of caller video to actually create our offer. So we've got a couple different use effects waiting for us. If the peer connection is ready, if we have tracks, disable the video message. We don't have tracks yet, so I'm holding off on that one. Once the user has shared the video, start WebRTCing. So that's us right here. Call status.video enabled. We're interested in offer created as well. Let's do this one. If there is no offer created, that is at the top. We have our set offer created is initialized at false, or offer created, I guess, is initialized at false. So it will be on load. This won't be true. So we only want this to run one time. So if that's not true, and call status.video enabled is true. Why would it be true? Well, over in video button, it just got enabled for the first time. Okay, I guess for the second time as well, but that's not going to be relevant because the offer will have been created. If this happens, there's no offer and the video has been enabled. We are ready to create an offer. So let's make that note, create an offer. This one's in all caps with exclamation points because we're not just excited, we are really, really excited. Just to keep the flow of the process clear here, we have video and no offer, making an offer. This is just for your own benefit. We're gonna call a function we are about to write called share video, and I'm gonna define it out here, const share video equals. This will be an async function. And on that note, anytime I have a use effect with an async function, and I usually label it async, so let's go ahead and just change this to share video async. So if there's no offer created and we have the video enabled, we're gonna call share video async, which is of course an async function. Inside here, we're gonna make a variable called offer, and we will do an await peer connection dot create offer open close. This is going to be blocking, so we will not move forward until it is finished. We'll go to our peer connection and do set local description, and we will hand it that offer. So this is, again, WebRTC 101. We are going to make our offer, which we can do now because back over in video button, we have added tracks to the peer connection. So we actually have an SDP that is going to be worthwhile. So, and again, we know that is finished because this is in our dependency. We have waited for that to be set. Now we can create a valid offer and we can set the local description. I'll put a note here. We can now start collecting ICE candidates because we called this, and we looked at that in the docs a little bit ago. Okay, a couple things that need to happen now. We need to emit the offer to the server. This will make it so that we have an answer option on our homepage now, but in order to do that, we are gonna need our socket. So we'll do const socket connection, just like we have done in the past. We will call the username. This is almost certainly gonna already exist unless you have changed the logic. We will already be connected, so we'll just get that same socket back. We'll do socket.emit. We'll call our event new offer, and we will send up the offer. So you can check server.js. This is inside of our signaling server. We pass up the offer, and it will add it to the available offers. So I'll go back just real quick. In home, come down here, available calls, we're looping through that, and that's what's creating those answer buttons. Available calls is getting set inside of our socket listeners here, available offers and new offer waiting. So what we just made here, this new offer, we're not going to spend time looking at it, but server.js is going to emit this offer to everybody else to let them know, hey, there's a new offer. So this is going to trigger that event. On the other side, we're going to do a set offer created to true so that we know not to run this again because the offer will be created. We will update our video message. So we'll do set video message. We'll do awaiting answer, ... Whatever you want to put in there is, of course, just fine. And let's add a note there quick so that our use effect doesn't make an offer again. And then right here, update our video message box. And then I'm going to throw a console.log in here that just kind of lets us know in the console where we are at. So what all did we do in here? Created offer, set local description, emitted offer, updated video message. And we have reached another waiting point where there's nothing left to do until someone answers our call. So a very brief review. When we get to this page, the first thing we do is make sure we have a local stream, otherwise we get out of here. Otherwise, typically, we would set the video stream to the appropriate tags. This use effect, just ignore. We'll add this later once we have a reason to do it. We are now waiting for the user to share their video. We don't have anything to do. We can't create an offer or any of that stuff until they have enabled their video, which will come on that video button. And we're letting them know that with this text right here on the video box. So once that happens, then this one will trigger. We'll call share video async, and we'll do all the stuff that we just looked at. Create the offer, set the local description, emit that offer, and then update a couple pieces of state. And now we are back in a position where we are waiting for an answer on the other side. We can test out where we're at in the app. I've got the tab open twice here, so I'm going to click join, and we'll do Peter this time. Okay, just like we expect, start the call. I pop up down here. Please enable the video to start. So this is waiting point one, where React is holding the process back. Once we click on start video, this switches over to waiting answer. Everything down here, where all that stuff happened that we wanted to, created offer, set local description, emitted offer, updated video message. We had a signaling event change, and that is have local offer. That has now occurred. And because we've set the local offer, or the local description, we can start collecting ICE candidates. So this is on side one. The only thing we can do now is wait. Wait for what? Well, if we come back over here and I choose join, and this time will be Bill, and hit OK, we have an answer call option from Peter. If I click on that, it takes me to /answer. Unfortunately, if I open up the inspector and we go to the console here and I click start video, it runs init video, but it doesn't do anything else because we are the answerer, and that is going to be our next task, is to add that code. We are ready to go over to our answer video component. And I just realized I copied the component when I originally made it, so I'm going to change this to answer video. It doesn't actually matter because what we export is the thing that matters, but I will update that in the repo. Answer video component comes with a new piece of data. It comes with the offer data. So let's go back to home and take a look at that. I said a long time ago, I said we would look at that. Down in our available calls, when we loop through, it comes with some call data. This is provided by available calls. That's the piece, that's the offer that is coming with this particular call. We send that to the answer function when we click on it. So the call data goes up. Inside of answer, there's call data. We set the offer data so that when we get over to the answer video, we have the offer data here. Just so that you can see it, I'm going to drop in here just temporarily. You don't have to do this if you don't want to, but I'm going to drop in there a console.log with the offer data in it. Back to the app, I'll be Akash this time. Drops me here. I will start a call. And we're here. It's blocked, waiting for start video. I click start video, and we get that same run of stuff here. Hop over to the other one. Gonna start over and join. I will be Jose. Hit OK. Okay, we've got the answer. I'm going to clear that out and hit answer. When we get dropped here, line 18, it renders twice because of the strict mode in React. But this is what we get back from the backend. This is the offer data. There is no answer yet for this particular call. We are about to create one. There are no answer ICE candidates because we are going to be the answer. We haven't provided any answer username, same thing. The offer, though, that has the SDP as well as the type. The offer ICE candidates, there are waiting, and then the offer username. So these three pieces of data are waiting from the other side. We need to fill these out. And again, this is our offer data that we have available here. So I'm going to clear that out. We've got a couple things that are going to be really easy to fill out. We need to send back to home if there's no local stream. So back over to our caller video. Up at the top, I'm going to copy this whole first use effect and paste it in. This handles that. If there's no local stream, then get us out of here. Otherwise, set the remote and local stream to the video tags. We don't need this part anymore because we consolidated that into one. Go down. We are still waiting to do this. This is going to be to clearing out the video message once we have our tracks. This is where we are at. We're waiting for the video to be enabled, and the answer has not been created. So it's almost exactly like what we had over in caller video here if the offer hasn't been created and the video has been enabled. So if we don't have answer created and call status.video enabled, then we're ready to move forward by creating an answer. So we will do add offer and create answer async. I'm sorry if you don't like my ridiculously long function names, but you will definitely know what they do. This will be an async function, and it's going to be very, very similar to what we just did over in caller video. So it's going to be pretty much this stuff here. We created the offer. Well, over here, the first thing actually that we're going to do is we can add the offer because we have it. We have it in offer data. I just showed it to you. So we'll drop in here and await. We will go to our peer connection, do set remote description, and we will put in there the offer data dot offer. Remember, offer data had those 6 properties. We are just entering the offer. I'm gonna go ahead and drop in here console.log. We will grab the peer connection.signaling state, and this should be have remote offer because, again, we just set it as the remote description. The next thing that we can do, now that we have the offer set, make our answer. So just like before, I'm going to add a console.log in here and put creating answer. Just for your reference, you don't have to put that in if you don't want to, of course. We'll make a const answer await, call peer connection dot create answer, open close, go to peer connection, set local description, and we'll put that answer in it, the answer we just created. This, of course, is the answer page, so our local is going to be the answer. Our remote is going to be the offer. Now that we've got this, we need to let the server or the signaling server know. So make our socket connection, pass in the username. Before we emit, though, we're going to update our offer. So we'll do copy offer data. Remember, this had those 6 pieces of data, but only 3 were filled out. So we are going to go to our copy offer data. We will set the answer equal to the answer we just made. That was 1 piece. We'll go to copy offer data and we'll set the answer username equal to our username. Now with our socket connection, we can do a socket.emit. And we already have presumably some ICE candidates, but just in case, I'm going to set here, we'll do a const, we'll do offer ICE candidates, and we're going to emit with ACK. This is the same as a regular emit, but we will get a piece of data back from the server. We are going to send up the new answer event, and you can go check out what's inside of the signaling server here. But we're going to send the new answer event, and we are going to send up our copy offer data. This will come back with the absolutely most current offer ICE candidates that we have. And I need to throw an await on there because this is going to take time, so it's an async operation. We'll take our offer ICE candidates though, and just to make sure, again, these are the absolute most current ones, we'll do a .for each. We'll call the one we're on C, and we will grab our peer connection and once again run add ICE candidate and hand it C. And you can throw in here console.log. I'm filtering these all over the place. Added ICE candidate from offerer. Okay, let's give this a try or refresh on both sides. Join, I'll be Maria, start the call. We get our enable video, start the video. Everything down here looks okay, and I'm coming through over to this side. Join, will be VJ. Okay, answer the call from Maria. Moment of truth here, we start the video. Okay, we added ICE candidates from the offerer. We found some ICE candidates of our own. If we come back over here, okay, so we got an error to deal with. The remote description is null. This is happening because we haven't added a remote description on our offer yet. So back over to our caller video, our last use effect here at the bottom with our call status, we are going to check to see if call status dot answer. If that happens, then we're going to run add answer async, open close. What would cause the answer to show up? Well, one more thing to keep straight here. In our client socket listeners, we were here a long time ago, but in answer response, this is where the answer gets added. What would cause that? Well, in our answer video, we just emitted a new answer. So that means that this use effect will have just happened. So we're going to define this function. It will be an async function. You can check the call status in here, but we will await the peer connection dot set remote description. We know that this exists because we just checked for it on line 64. So that's what we will hand in there, call status dot answer, and we can console.log in here, answer added with a couple more explanation points. So if all goes well, this should be the end of the process. It looks like it already worked. Yep, so the feed is already coming through. It didn't wait. I'm on my local. We need to do two things briefly here. We got the hang up button, and we need to get rid of this obnoxious thing. Inside of both of these, we're going to have this in the same spot. I've got this empty use effect. If we have tracks, we want to disable the video message. So it's not sitting on my face there. If the peer connection exists, we will go to the peer connection. We're going to listen for on track. We're going to run a function. We will get the event here. And if, and I'm going to use optional chaining here, if the event exists and it's got streams, we will check the length. So if this is an array that has length, then we are going to set the video message equal to the empty string. Otherwise, we will set our video message and put in there disconnected because we stopped getting, we do have tracks coming through, but the length is now null or 0, I guess. So we'll set the message here to disconnected. So if I save that on the caller only, come up and let's just kill the server to make sure that we are fresh, refresh both pages so that we don't have any extra stuff coming through, fire the server back up, join, I'll be Rob, start, join, or start the video, I guess. Over here, join, I'll be Akash, okay, answer. Once I start, everything happens down here. Okay, we still have this message here, and we're set over here. It's the same feed in both places because I'm using the same feed in both places. Let's get rid of that obnoxious note there. Take what we've got in caller video, so grab this entire use effect. If we have tracks, disable the video message, bring that one over here, and paste it over top of that. And that should be enough. React reconnected and did everything, so we got a goofy error there. Let's just start over. Join, I'll be Rob2 without having to restart the server. Start the call, start the video, join, Akash2, answer, start. Okay, no message here, no message over here. We have completed our connection. If you would like to, I can show you how Hangup works. Hangup button is inside of action buttons. It brings in a couple pieces of state. Down here, we've got a button. If you click on the Hangup button, it will, assuming there's a peer connection, make a copy of call status, set the current status to complete, and we close the connection, remove the ICE candidate listener, remove add stream listener, set the peer connection itself to null, and then set the 2 video tags to null. So if I come back over here and hit hang up, all of that stuff happens in one swoop. And if you want to, you could navigate the user back to wherever you would like. That is a ton. We've got 3 moving, confusing parts in our signaling server doing socket.io or WebSockets back and forth. We got WebRTC doing its thing, React doing its thing, and then of course the caller and the offer internally are doing their things. So many things to keep straight, but it is so gratifying, and there are so many wonderful apps that need to be made with WebRTC that you have a good starting template from. Thank you so much for watching. Watch for more WebRTC videos, and I will see you next time.